Hello everyone, welcome to In 5 Minutes. In this video we are going to see the next problem on type 2b. So this is our question. Solve this integration over the area between the circles r equal to 2 sin theta and r equal to 4 sin theta. So in this problem we are given the polar coordinates directly, and r equal to 2 sin theta and r equal to 4 sin theta are two circles. So we have to find the area between these two circles. So always remember, whenever we have r equal to 2a sin theta, this is in a polar form. Whenever we have this equation represents a equation of circle passing through origin and whose center is on positive y-axis. Okay, so r equal to 2a sin theta circle is something like this. That is, it is passing through the origin and this upper point will be 2a. Then the radius will be a. Okay, so a will be the radius of this circle. So now in our case, let's say this circle is r equal to 4 sin theta. So this point is 4, then radius will be 2. Similarly, r equal to 2 sin theta will be a smaller circle. If we compare this equation with this equation, we get 2a equal to 2, we get a equal to 1. So the radius of this circle is 1. And when we compare this equation with this equation, we get 2a equal to 4, we get a equal to 2. That means the radius of this circle is 2 and the radius of this circle is 1. So this r equal to 2 sin theta is the smaller circle and r equal to 4 sin theta is the bigger circle. So this smaller circle will also be something like this. Okay, so this is our smaller circle whose equation is r equal to 2 sin theta. In this way the circles can be represented in diagrammatic form. But we have to perform this integration over the area between the circles. So what is the area between the circle? This is the area between the circle. So we have to perform our integration from this point to this point. This is the area between the circle and we have to cover this entire region. Okay, so now we do not have the limits of integration, so we have to write the limits of integration. For that we will consider one strip. Since it is a polar coordinate, we will consider a radial strip. So we consider one strip starting from smaller circle and ending on larger circle. This is also called as ray or radial strip. So we consider this radial strip starting from this smaller circle or ending on this larger circle, because we have to cover only this much area. Okay, that's why we are considering. We are not considering this entire strip, because if we consider this entire strip, it will be the area of entire circle, but we want the area between the circles, so we consider this strip. So what is the lower end of this strip? Lower end of this strip is on this circle whose equation is 2 sin theta, so r equal to 2 sin theta, and the upper end of this strip is on r equal to 4 sin theta. So we have considered our strip. Now we have to rotate this strip so that entire region is covered. So we will rotate this strip starting from this point. We will rotate in this way. Okay, so we will rotate this strip in this way only till this point. So we are rotating from this point to this point. Here theta is 0 and here theta is pi by 2, and when we come here theta is pi. So our theta is starting from this point and it is going till here, so that our this entire region is covered. Okay, so theta is going from 0 to pi. So theta is going from 0 to pi, and r is going from 2 sin theta to 4 sin theta. R cube dr d theta. In polar coordinates, always remember, first we will perform integration with respect to r, then we will perform our integration with respect to theta.